Hi everyone, this lesson is going to be about functions and just different parts of what you need to know about functions. Functions are something that we use in this class and future classes, so a very important concept. Alright, so to begin with here, we're going to talk about the a relation, domain, range, and identity functions. A relation is just a set of ordered pairs, and so when you're talking about a relation, you can actually write out the set of ordered pairs that represents that relation. Domain is all the first components of the ordered pairs, so that's going to be our X. And then the range is the second component, so that's going to be the Y. A function is a relation in which each first component in the ordered pair corresponds to exactly one second component. So this means that in a function, the x coordinates do not repeat. Do not repeat. And if they do not repeat, then it is a function. If they do repeat, it's not a function. It may look like it's a function, but this is kind of the rules for that. And then on this helpful hand, a function is a special type of relation, so all functions are relations, but not all relations are functions. So that's what I was saying, you might have a set of ordered pairs thinking, okay, this is a function, but it may not be because some of your x coordinates are the same. All right, so we're just going to take a look at this. The domain and range of each relation. Find the domain and range of each relation. Also determine if it is a function. Okay, so we are just going to list out every number, every x coordinate basically that's in this function. If it is a function, right? In this relation, sorry. So we write this in set notation. Now you can just list them in the order that they're given, or you can put them in a numerical order. But remember, the domain is the x values in each of our ordered pairs. And then the range would be the y values, right, or the y coordinates. Notice we have a 9, a 3, and a -5. We're only going to write the 9 one time. And so we have listed the domain, we have listed the range, and then we have to determine if this is a function. So you notice that there are 4 different x coordinates. None of them repeat, so this one is a function. Yes, it is a function. All right, so we've answered that question. Okay. On this next one, you'll notice that we're pairing an animal with a lifespan, and these also represent, they represent an ordered pair, right? A polar bear has a 20-year lifespan. Now, I'm going to be a little lazy on this one. I'm going to call my input, right, the input's domain. So my domain is polar bear, cow, chimpanzee, giraffe, gorilla, kangaroo, red fox. Now, if I was really having to list that, I would have to write that out. And then my range, right, would be these numbers. I will go ahead and say the range then is 7, 10, 15, and 20. So I'm listing that one out just because that's shorter and I don't have to write out all the animal names. And then on this one, it would make sense that it is a function because a polar bear only has one average lifespan. So we're not going to say the polar bear has a lifespan of 20 and 15, right? We wouldn't do that. And so for this, in my relation, every animal is paired with only one lifespan, right? Polar bear's 20. A cow's 15, a chimpanzee is 20. But notice the animal, the domain, the x coordinate is not repeating. Okay, so yes, this is a function. And on this one, I'm going to put a because, so I can kind of explain that and have you thinking, because for each input, the x's, I'm going to say x, there is exactly, or only, or however you want to say it, there is exactly one output, which is the y. It is sometimes handy just to think of your x's and y's as inputs and outputs, because when it's functions, sometimes students get kind of bogged down on how this works. And so that's just another way to look at it. Okay, next. All right, find the domain and range again, determine if it is a function. So one way you could look at this too is to actually write out your relation. All right, so in this case, let's write the relation. My relation is A1 and A2, B3, and C3. Whoops, might want to put my parenthesis and a C. Okay, so there's my relation, and then when I look at my domain, abbreviated with a D, I'm going to list, right? I have ABC, and then for my range, I have 1, 2, 3. Now, when you look at the relation, and this is one of the reasons I decided to go ahead and write out the ordered pairs in the relation, so we could look at this and think about. In my ordered pairs, do you notice that 2 of my ordered pairs have an A? So that means that this one is not a function, right? No, this relation, I'll write it up. This relation is not a function. Now, you really can say yes or no, but I'm trying to explain and describe and help you to look at this in a way that's going to help you learn it. So that's why I'm writing out more. All right. So here we're going to talk about the vertical line test. What is a vertical line test? Well, a vertical line test is a way that we can determine if a relation is a function, and we can do this on a graph. So we can simply look at the graph and determine whether it's a function or not. And then we're also going to find the domain and range of these relations. So I actually like to determine if it's a function first, and then we write the domain and range. It doesn't matter which one we do first. But if you look at this, right, if I write, let's see, I'll use this one. If I put a vertical line anywhere on this graph, do you see that my vertical line, any of my vertical lines are intersecting only one time, right? So if they intersect only one time, it is a function, right? No matter where I draw the vertical line, I will get only one intersection with the line that is graphed. And that's what I'm looking for, right? On my graph, which is the graph of this line, are there any vertical lines that would intersect at more than one time? So this is a function, right? Yes. Oh, I've got my line tool going there, so I don't want the line tool right now. So yes, it is a function because it passes the vertical line test. Really, that I'm saying is that yes, because a vertical line will only intersect on this line one time, or on the graph one time. Now let's look at domain. Now on this, we're going to have to write it in interval notation because I don't have just ordered pairs I can name. If I tried to name the ordered pairs on this line, that would never happen. There's no possible way for me to do this because the line continues on and on and on. So my domain in this case is about the x coordinates. So try to just ignore the y's and think about the x's. What's happening with this line? Well, the line keeps going, right? And it's going to continue getting wider and wider and wider and wider. So that means that my domain in this case is going to be from negative infinity to positive infinity. Basically all real numbers, right? All real numbers are included in my domain. I name this using interval notation. I write it using interval notation with negative infinity to positive infinity. And then on the range, it's actually the same thing, because as it gets wider, it's going to go in the negative and positive direction on the y-axis, right? So if you're just looking at the y's, the same thing happens. And I'm from negative infinity to positive infinity. All right. Okay, let's look at this next question. And you can see that if I draw some vertical lines through the circle, they're intersecting more than once. In fact, they're intersecting 2 times. Now, there are a couple of places I could draw a vertical line that would only intersect 1 time, but this is about any vertical line anywhere on the graph. So in this case, it is not a function. And it's not a function because any vertical line drawn on the graph could intersect it more than once. You could say it intersects it in 2 points. You could say that there's more than one output for some of my inputs. You know, like if I named the ordered pairs at 0, right? There's a 0, 3, and there's a 0, negative 3. Therefore, the x's repeat. And so it's not a function. I've tried to give you a few reasons why it's not. My domain for this one is going to be from looking at the x's, so left to right, right? I'm at negative 3 to positive 3. And notice that I'm using brackets because negative 3 and positive 3 are included, right? They are part of this graph. And then on the range, it starts at negative 3, right, to positive 3 on the y-axis. So I'm writing my range in the same way. Okay. Well, I'm going to stop this video and we will finish this lesson, or hopefully we'll finish it on the next video. I may have to make 2, I don't know. We'll see. Anyway, let's pick this up on the next video.